Hello everybody, this is the fifth video clip for chapter 2. Okay, previously what we have learned is that if you have a derivative of a constant multiplied by a function, okay, so you can pull out a constant and then a derivative go to a function itself, and if you have a derivative of two functions, so okay, added or subtracted, so it means that you can find a derivative of each one of them, okay, separately. After that, you just add them up or subtract them up as it is. Okay. However, we also have some example showing that if you got two functions multiply, and then you cannot just separate the derivative directly. Okay. So today we are going to see, like, if you got two functions, okay, multiply, then what we are going to do. So this one is called a product rule, and the product, it means the multiplication. Okay, so here if your f and your g are differentiable functions, okay, then the derivative of the f and the g, okay, becomes the f multiply a derivative of g plus the g multiply a derivative of f. Okay, so there will be two terms added. The first term, okay, your f just copy and then multiply with your derivative of g, and then the second term your g copy and multiply by a derivative of f. Okay, so sometimes we are going to say that here is the first, there is the second, so it becomes the first, okay, and then derivative of the second plus the second, and then derivative of the first. Okay, so this is the way that we usually memorize. Okay, so look at this one, this problem. You got your f, okay, here is your f as x squared, and then your g as the psi. So you have the first derivative of the second plus the second, and then derivative of the first, you see. Okay, this is the formula, and then your x squared copy, and then a derivative of psi become a cosine of x, and this one your psi just copy, and then a derivative of x squared becomes 2x, but then we usually write down in front of your cosine of your sine and cosine, so that you don't get confused. Okay, all right. So how about this one? Actually, if you want, you can do a multiplication first, okay, before finding a derivative. However, it's not going to, help that much, because upon multiplication, you still have this term e to the x multiplied by x, which is two functions, one exponential, one polynomial, multiply each other, okay? So we are not going to do it that way. So again, we are going to look at it as the first and the second. So here is your first, there is your second, the whole thing. So it will be the first, okay? And then derivative of the second, which is 2 derivative of x minus a derivative of a square root, which is x raised to the power 1/2, okay? Plus the second, and then derivative of the first, which is a derivative of e, and then a derivative of a constant 2.5. Okay, so the first one, you just copy your first here, okay, and then derivative of x becomes what, 2, and I mean becomes 1, right? But this one you have 2, and here you got 1/2 x raised to the power negative 1/2 plus 2x minus square root of x, and then here e to the x and 0. Okay, so this one, if you want, you can further rewrite into 2 minus a 1 over 2 square root of x, and this one is just simply e to the x multiplied by 2x minus square root of x, just like that. Okay. However, I mean, again, this one will be good enough to be your final answer. Okay, if we don't ask you to do further simplification. Okay, all right. Next, it is a quotient rule. Okay, a quotient rule. A quotient, it means that you have a division. Okay, okay. So a derivative of this one, f of x divided by g of x. This one will be a little bit complicated. Okay, so for the product, okay, if you I mean, if you switch the thing, okay, if you write this one first followed by that one, is still okay because you're followed by the addition, right? I mean, each of them separate by the addition, so which one go first, it doesn't matter. However, for a quotient, okay, this is very important that which one go first, because you are connected two terms by the subtraction. Okay, so this one, your g go first, and then a derivative of f minus your f copy, and then a derivative of g over, don't forget this one, the g square. Okay, and this is the common mistake that you usually forget, divided by the g square. Okay, so this one usually we are going to look at it as the top over the bottom. Okay, so usually we are going to say that the bottom, and then derivative of the top minus the top derivative of the bottom, okay, over a bottom square. Okay, so usually we are going to memorize it like that. Okay, a bottom derivative of the top minus the top derivative of the bottom over the bottom square. So here's your top, there's your bottom. Okay, so it becomes what? The bottom first, okay, derivative of the top, derivative of 1 is 0, derivative of x squared becomes 2x, okay, minus the top, derivative of the bottom, 3x becomes what? 3, e to the x become e to the x itself, and then over your bottom square. Okay, this is good enough to be your final answer. However, if you want, you can just rewrite it a little bit into this kind of thing. Okay, minus 1 plus x squared, and then 3 plus e to the x over 3x plus e to the x squared. Or if you really want, this one becomes what? 6x squared, and this one becomes minus 3x squared, and then you can further simplify. However, usually we just keep it like that. Okay, so how about the tangent? What is the tangent look like? Okay, so actually a tangent, okay, it consists of the top as your sine, okay, and your bottom as your what? Cosine. Okay, so here you have a top and a bottom again, okay, divided. So we have a bottom first, derivative of the top, so derivative of sine become a cosine, right? And then minus, okay, the top, which is your sine, derivative of the bottom, which is a negative sine, right? Derivative of cosine becomes negative sine over cosine square. Okay, so this happened to be what? This happened to be cosine square plus sine square over cosine square x. So it happened to be 1 over cosine square x. And what is the 1 over cosine? It is a secant. So this was secant square x. Okay. How about this one for the cotangent? It is again a derivative of, you can look at it at the several angle, okay, you can, let's pretend that this one is 1 over tangent. Okay, we can do it this way as well. So we have your bottom derivative of the top. So now your top is just a constant. So a derivative of a constant is 0 minus the top derivative of tangent. We're just saying that it is a what? A secant square over your bottom square. Okay, okay. So this one is gone, right? Because it is 0. So here you have 1 over cosine square, and then a reciprocal of tangent. Okay, usually the tangent is a sine over cosine, right? So it becomes cosine square over sine square. So the cosine square will be cancelled, right? And you end up with negative 1 over sine square, which is a negative of cosecant square x. Okay, so you see a derivative of tangent becomes secant square, but a derivative of a cotangent become cosecant square as well with negative sign. Okay, so this kind of thing will be like something that pair up. Okay, for example, sine will pair up with cosine, okay, as a derivative of each other, right? But however, if you find a derivative of sine, it becomes cosine. Derivative of cosine become negative sine. Okay, this one as well. The tangent, okay, will pair up with a secant, but it will be secant square. A cotangent will pair up with a cosecant, but it will be a negative cosecant square. Okay, so you really need to look at it very carefully. Okay, so for example, if you want to find a derivative at this given point, first of all, you need to find a derivative at the arbitrary x first. Okay, so you find this one. It is a product, right? So you have the first derivative of the second. Okay, derivative of 3x becomes 3. Derivative of sine, it is a cosine, plus the second, and then derivative of the first. So you have x squared, which is 2x, and then the cosine, which is negative sine, remember? So it means that your f prime at pi becomes what? So you just replace your each and every x by a pi. Okay, here 3 pi sine pi 2x minus sine pi. But your cosine of pi, it is -1. Okay, so this one with a negative become a plus. Okay, and your sine of pi becomes 0. So this one is, oh, I forget, 2 pi. So this one is also 2 pi. Okay, so here you have what? 4 pi square minus 4, and then 6 pi square. So totally you have 10 pi square minus 4. Okay, so we just try to challenge you to find the tangent line, okay, to the curve y equals to that f of x at the point x equals to pi. Okay, what it is. Okay, so look at this one. The next one, your g in terms of a quotient, right? So you are going to find your g prime, which is a bottom first, right? And then derivative of the top. So you have 6. Derivative of secant is what? Oh, sorry, the tangent, it is what? Secant square. And then minus the top, okay? The top. And then derivative of the bottom. So the derivative of 2 is 0. Derivative of x, it is 1. And then a derivative of the exponential, it just the exponential itself over, don't forget, the bottom square. Okay, and because you need to evaluate as a number, so you don't really need to simplify anything, just evaluate first. So it means that g prime at 0 it will be 2 and then 0, right? And then e to the 0, it happened to be 1, okay? And 6, and secant of 0, it happened to be 1. Remember, a secant square of 0. However, the tangent of 0, it happened to be what? It happened to be 0 because sine 0 is 0. So this one, it has -1 plus 1, and it does 0 again, over 2 minus 0 and 1 square. Okay, so this one becomes what? 18 over 9, which becomes 2. Okay, again, if you want, then you may challenge yourself by finding the equation of the tangent line, okay, to the curve at the point x equals to 0. Okay, okay, it's not that difficult because we already have a slope here, right? Okay. So sometimes if we want to test you like how you use the product rule and the quotient rule, we don't really need to give you a formula for the function, but we just leave your function h as f of x times g of x without seeing what the f and the g is, okay? So here, your h prime, okay, this is a product, right? Oh, and we need to find h prime at 2, right? So we find h prime at x first. It is the first derivative of the second plus the second derivative of the first. And then your h prime at 2 will be simply f at 2, g prime at 2, g at 2, f prime at 2, okay? So f at 2 is already given to be 3, g prime at 2 is given to be 7, and then g at 2 is 4, and f prime at 2, it is -2, so you have 21 minus 8, which is what, 13, is it? Okay, so the next one is a quotient, right? So you find again your h prime, which is the bottom, and then derivative of the top, don't forget a parenthesis, minus the top, derivative of the bottom. So you have to pass the 1 first. So a derivative of 1 is 0, and then this one is f prime, right? And then don't forget over your bottom, the whole thing square. So it means that your h prime at 2, it is 1, and f at 2, g prime at 2, g at 2, and f prime at 2 over 1 plus f prime at 2, the whole thing square. So we have 1 plus f at 2 is 3, g prime at 2, it is 7, g at 2 is 4, f prime at 2, it is -2, and then 1 plus your f prime, sorry, you see, this one, I copied the wrong one. Actually, this one is just f at 2, okay? So 1 plus f at 2 is 3 square. So you have 28 plus 8, right? Over 16, okay? So if you want, then you can simplify. It is a what, 36, right? So it is 9 over 4, I guess, okay? So you need to check my calculation as well, especially in terms of numbers, okay? All right. And we would like you to do the exercise as 3.1, number 3 to 34, and also 3.2, number 3 to 26, and number 31, okay? So before we end this video clip, let us go do a quick thing on the derivative of a trigonometric function. This one we already given, right? A derivative of sine is a cosine. A derivative of cosine is negative sine. A derivative of the tangent, we use the quotient rule to have a secant square. And the derivative of cotangent, it is a negative cosecant square. So what is a derivative of a secant? Okay, so it will be the what? It will be 1 over cosine. Okay, so it is a quotient rule again. A bottom derivative of the top minus the top derivative of the bottom over your bottom square. Okay, so it happened to be sine of x over cosine square of x, or you can look at it as sine over cosine and 1 over cosine, which will give you a what? Sine over cosine becomes a tangent, right? And 1 over cosine becomes secant. So it means that a derivative of a secant, it becomes two function multiply. One of them is a secant and another one is a tangent. Okay. So on the other hand, if you perform a derivative of a cosecant, okay, so it is a 1 over sine, okay, which is again the bottom derivative of the top minus the top derivative of the bottom over your bottom square. So you have negative cosine, and then one of them divided by sine, and the other one is 1 divided by another sine, because you got sine square here. So we have a negative cosine over sine. It is a cotangent, and then a cosecant. Okay, 1 over sine. So it means that a derivative of a cosecant, okay, become two terms. One is cosecant, another one is cotangent multiply. However, you have a negative. So you see all the attached with a what? Negative, okay? And the one without the attached with all positive. So this is the way we like memorize the trigonometry derivative, okay? So we are going to stop this video clip right here, and then we will continue with the higher derivative for the next one. Bye-bye.